Hey YouTube, Do-It-Yourself Junkie 369 here, and today I'm going over some stuff you should look into or research if you're going to buy a Smithy 3-in-1 machine. This particular series is the Granite, and it's a 1340, meaning it has a 13-inch depth work area and then 40 inches between centers. The other version is 13 by 24. So they both use the same cross slide, but then the lengths are different. Brand new, one of these machines will cost about $7,000 with a stand and tools, depending on what size you get and what motor you get with it. There's two versions of motor available. The one is 120 volt, the other is 240. Right now, I don't have the cover that was on this. It's over here on the bench. And one of the areas you want to look at is up here at the belts. This one belt's fraying a little bit, but it still has some useful life. If that's going bad, it's not really a big issue. You can order a new one. On this end, there's a door. You just turn the knob to unlock it and look in there. Right now, the gear set that's installed is for cutting your standard gear or threading. And then it has a separate gear set that is for cutting metric gears. And then there's a 2-speed pulley system in here to reduce your speed, with the slower speeds being inside the dial, ranging from 0 up to 1300 RPM, and the outside dial being your faster speeds that range up to 2800. Here is your selector for switching from your vertical mill setup to your lathe setup. Usually, if you want to get those to engage, you're going to have to maybe wiggle your headstock, your chuck here, your lathe chuck, or up here to get that engaged, because it's just a big tooth type engagement that locks together. That can wear out. There is some stuff you can do to adjust. It's probably not in the manual. I haven't read the manual yet, but some machines I've seen, they can't get enough engagement, the thing's slipping, so people will go in and drill another hole beside the stock location to allow that switch to move over further. Then you have selector for your cable drive here, which you can either put it in lathe or now it's stuck, mill. And again, if it's having trouble engaging, you just need to probably wiggle something back and forth. You also have your lead screw direction that controls your power feed. And then down here you have your gearbox, which you can select speeds based on what type of threads you want to cut or how fast you want your tooling to feed, based on what you're cutting, what type of operation you're doing. As I said before, it's a 3-in-1 machine. This is capable as running as a drill press. And so you have your standard type drill press control. And then this button right here, if you push that in, it locks this. And now you have a fine adjustment, which has thousandths, 1,000th inch increments on the dial. And we'll do some videos later on how to utilize each one of these and how to set it up. This particular one came with three-jaw chuck. That's very basic of what you should at least have. If you can get a 4-jaw, that's awesome. Basically, above the base machine, any tooling you can get, if you're picking up one of these used, is a real bonus. With this, if you're getting a chuck that's installed, you should at least get the chuck handle. And the key here is never leave that sticking in here. Always keep it in your hand, and when you're done with it, preferably put it somewhere out of the way. I don't even like having it on the machine. Another key bit is this wrench handle. That over here can loosen these two points, which lock the entire mill head in place. And then if you unlock those, you can adjust the height. And the key here is you want to make sure not to adjust it all the way down and not to adjust it all the way extended. And if you're buying it used, there's not really a way to tell if somebody's done that. Maybe just talk to them and get an idea if they're a competent person and likely haven't done that. One thing you can do though is turn on the machine and see if you hear any bad noises coming out of this unit caused by damage from extending or compressing it too far. The power going up into here is fed through a plastic bevel gear. I have had one of those go bad. It was either caused by adjusting it one way or the other too far, or improperly adjusting the gear mesh, which is covered in the manual how to properly set that up. So on the machine I used in the past, my theory is they adjusted that to where that gear was pressing on the other gears too hard. There's too much friction and it just sheared the teeth off eventually. One thing to look at is you want to make sure these ways here for the bed don't have any damage to them. So pitting, rust, nicks, gouges, anything. Light rust isn't too bad, but if you're seeing it there, you have to kind of wonder how the rest of the machine is. Also, look at the environment that the mill is in. Like here I have it in my garage. When I picked it up, it was in a guy's workshop, which was beside a dirt road, and the doors were open quite often, and cars drive by and dirt comes in and settles on everything, and that dirt and grit will ruin these. Luckily, the machine was located far enough back in the shop, it didn't get to see a whole lot of that, and I don't think it really saw that much use. And so nothing there seems that bad. Right now I just got done cleaning it, so I do need to add some oil in here before I move around a whole lot. And basically the cleaning was, there was a whole bunch of chips on here, and I cleaned all those off. I got rid of the dirt. There was some surface rust on the truck, some up here, but nothing that was going to cause any issues. It was on the outside of areas that didn't affect the precision of the mill, or didn't affect the precision of the tool in any way. Another thing you want to kind of be aware of is Gibs. And Gibs are basically pieces of metal in there that are pressed on by screws, in this case down the side of the table, which basically adjust over to create a really tight fit between the cross slide and the longitudinal axis of this table. And what that does is it keeps it from flopping around. If I were to go in and loosen all these, it'd flop back and forth quite a bit. There's a little bit of play in it right now, but not much. One thing you have to worry is if it's adjusted real tight, you'll have trouble turning this wheel, moving the table back and forth, and that's bad because your Gibs will wear out quicker than normal in that case, and then you'll have a machine that's worthless because you can't take that slop out. If it's too loose, maybe the person just didn't know what they were doing, but you want to make sure to adjust it before you use it, because if it's that loose, your part's going to be garbage when you're building it. You won't have any sort of precision as you're milling along. Your cut's going to be, or tool path is kind of going to be all over the place as your table flops back and forth. As far as some other damage to watch out for, there's the possibility of damage here on your tailstock if they ran it too close to the headstock. They could get hit by the jaws on the chuck, and that just loosens up over here and then slides. So they could actually run it all the way over there and run it into the headstock if somebody was trying to work on a really small piece. And this has a little bit of damage that might have been caused by that, but it's not in anywhere that's going to cause a problem with operation of the machine or getting precise parts out of it. Like there's a small chunk missing, but there's nothing protruding or sticking up that needs to be ground down. The other area you have to watch out for is the table being hit by the jaws on your lathe chuck. This one does have some damage here on the corner of this, and in that case, if you run your finger across here, you can feel it sticking up. If it's small, it's not the end of the world. Where it becomes a problem is if any of your tooling or your vise sits on top of that, it will now be out of level and not flush with the table. One way to fix that though is you can take a stone and kind of redress that area and deck your table. Another area to watch out for is look at, if you are getting a vise, how's the vise being stored if it's not already mounted? A lot of people will take those out and they'll set them down on the floor with the mating surface down, and that can cause raised spots, and then you have to go and redress the bottom of your vise. Otherwise it could be sitting in a position that's not flush with the table. What's up?
I'm hungry.
Well, it's almost time to go get dinner. We'll be leaving here soon. You kind of want to make sure you don't hear any grinding sound. There's guards here that are kind of protecting your power feed screw, and hopefully those are still in place and didn't get ripped off. Like I said, I don't have the lid, it's sitting over there, but it does exist. I mean, other than that, you're just basically looking for obvious damage and whether or not that's going to impact something, or looseness, or noises that shouldn't exist. Really, if you know somebody that is a machinist or has used lathes and mills in an actual machine shop, like maybe going through a college course or somewhere they work, if you can come across one of those guys, all the better to take them with you. The only problem is a lot of machinists I talk to view Smithies as kind of a horrible Chinese built machine that you should stay as far away from as you can. And best I can figure, their experience probably stems from the non-Granite series of Smithy. Granite is relatively new depending on how old of a person you're talking to, and they might not have come across that before. And so the other machines might have had accuracy issues with their measurement, or precision issues with being able to produce nice parts. Down here you have half nut, and that's why really you want to go with the Granite series. There's several different series of machines. In my mind, you only want the Granite series. Big thing on that is the half nut engagement, which makes cutting threads on the lathe a breeze. I I've researched how to do it without it. It is possible. It's just a nice feature to have. I mean, you can get by without it, but why bother? Then up here you have your feed lever. That, if you flip it one way, it will feed your cross table in and out, depending on which way you have that screw turning. And if you put it over and push down, it will engage the longitudinal axis, and that's really good for both milling and turning parts on the lathe. There's really not much here to look at on that screw, other than just running it, making sure stuff runs correctly. The other thing on these controls, again, they have the dials that have 1/1000th of an inch increments. But the other side of that is there's some gear lash. Basically what gear lash is you're moving it this direction, it moves. You go to move the other direction, there's a little bit of movement that can occur before this actually starts to move. And you can usually feel it's in a loose area. So we'll line this up with 0. And in this case, the lash is about 0.006. There's a brass nut in there, or split nut, that you can use, and you spread that apart to engage the threads on both sides, and that takes out some of that gear lash. That's another thing, like the Gibs, you don't want it adjusted too tight or you'll just wear out stuff too soon, but you don't want excessive amounts of gear lash. Like if you're above 10 thou, that's probably too much. Same thing on the longitudinal feed. You go right there, move it back. That one's a little bit bigger. It's at almost 9 thou. Still, with the way you normally run these machines, you only move in one direction. You don't move one direction and then move back and try to measure the other way, because you can't account for that gear. I mean, you can account for that gear lash, but usually it requires resetting and basically figuring out where your tooling is at. One thing I'll say about this, from what I can remember, most machines I used in college in the machine shop, one rotation around was 100 thou, or 1/10 of an inch of movement. And on this cross slide, you can see it hits 90 and then goes back to 0 after 10 marks, which is 100 thou. Down here on your longitudinal axis, I found this out the hard way while I was making a part one time on one of these machines. It gets up to 90 thou, and then you have 1, 2, 3, 4, 5, 6, 7, 8. So when you get back to 0, it's actually 98 thou, or 2/1000 short of a full 1/10 of an inch. And so normally you go and you count, and there's one time around, that's 100 thou, 2 times around. So you're there counting rotations. That's 2/10, 3/10, 4/10, like that. And that's why in the one video I talk about, when you're machining, don't have any distractions, don't let anybody talk to you. If you're going to talk to somebody, shut the machine down. Part of that is you're sitting here counting rotations, and you do not want to forget where you're at, because then you're either going to have to stop and figure out where you're at, or you're going to have to run the risk of messing up your cut and ending up with the possibility of being 100,000ths or 1/10 of an inch out of whatever you're hoping to get. Some used machines out there might have a DRO mounted, which gives you a digital readout of what's going on. Those are not affected by gear lash. So they're very useful in that regard. And they're a lot easier to use as long as you know how to do some basic setup on them depending on what you're trying to do. This one did not come with that. If you do find one, expect to pay a little bit more possibly. Down on this end, there's usually a wheel with a handle sticking out of it. That's that longitudinal feed. I don't ever use this. Or I guess I should more appropriately say, I haven't used this yet. Basically, I control everything over here. The handle's been removed because when you're doing power feed, this is spinning around, and that's just something to either hit you or get snagged on something. And in my mind, it's not worth having. Here we have our tailstock. That's an M3 taper on this, whereas our headstock is an M4 taper. Again, it has the dial that has the readouts of thousandths of an inch, and it actually, one revolution is 100 thou. At the minimum, I would hope that whoever's selling you the machine would include some basic tooling, such as your arbor and chuck to mount a drill bit for drilling operations, and at least a dead center and your arbor and chuck for your tailstock. Other thing, besides your lathe chuck, you really want them to include a cross slide, which I don't have mounted on this machine. I took it off while I was doing the cleaning. For those of you that are unfamiliar with one, it's just a compound slide that you can set at an angle, and for lathe operations, it holds your lathe tooling to make your cuts, and you can set it at an angle and make angled or tapered cuts. That one's the basic style that comes with Smithy machines. You can get a quick release style that is roughly an AXA size quick change tool post. If yours comes with that, it'll probably bump up the price a little bit. Other stuff that could come with it is a vise, either 3 or 4 inches, probably good. You're not going to be able to use much bigger than that. As far as the specs of the machine, some important stuff. We basically already covered table travel, where you've got like a 13-inch table by 40 inches between centers, or in the smaller machines, 13 by 24. The swing over bed, which is how big of a workpiece you can fit in here, that is 13 inches. So it kind of causes a problem for some people. Like, do you run a small AXA size tool post, which is usually good up to a 12-inch swing, or do you run a BXA, which is a beefier tool post, so it's stiffer and results in more precision, but the tool post is right at the bottom end of that swing, where they shouldn't be used really on anything that is smaller than 12 inches. I would tend to think you want the AXA because it's going to be mounted to this table, and the swing over the table is only 7.5 inches. Now for threading capability, you can run anywhere from 7 threads per inch up to 52 threads per inch. So I've seen a couple of tabletop lathes that I've looked at, not the really tiny mini lathes, but some serious like 30+ inch lathes that you can just buy for your garage. And those will run, I want to say, down to 4 threads per inch and up to about 64 threads per inch, somewhere in that range. And so this is missing a little from each end of that spectrum, but it's not going to really impact you unless you get the oddball, something really large or something really fine, really small. there's a good chance you're not going to exceed this machine's capability for threading unless you run into one of those areas. So pretty important, 7 threads all the way up to 52 threads per inch. And whatever the equivalent is for metric, it's capable of that. Now your x-axis travel, on the small machine you get 20 inches of travel, on the large machine you have 35 inches of travel. And then for both versions, the y-axis is 7 inches 5/8. The quill travel is 4 inches 7/8. Important thing to note, you do have some indications for depth drilled here. Those are in 10,000ths increments, whereas everything fine adjustment is in 1/1000 increments. Your drawbar up here is 7/16 by 20, and it's going to use R8 style taper tooling, such as collets, tool holders, or anything else that you want to put in here, like your arbor to hold your chuck. And then one last thing that you want to be aware of is your center of your spindle to your chuck is 8.5 inches. So that means whatever you're working on, you can only go 8.5 inches with it that direction from the edge of it, depending how you mount it up. If you remove the chuck, which I really suggest you do when you're doing your milling operation, if you want some extra distance, from spindle center to lathe spindle flange is 11.25 inches. So you get almost an extra 3 inches out of that. And then your spindle can be adjusted all the way down 4 inches from the table to as high as just over 13 inches to the table. And basically you want that as low as possible to your workpiece, because the less you have to extend out this spindle or the quill, the stiffer that whole setup's going to be, resulting in less flex and a more precise part. Important things to note other than the capacities I listed: your tool size up here, you really shouldn't exceed 1 inch. I would say if you're running a fly cutter or a surface end cutter, or no, that's not right, or a surface cutter, you're probably going to exceed that. I think I've run an index surface tool that was like a 8 cutter, about 2.5 inches. It handled that fine. Probably could run like a 2.5 inch fly cutter on there, no problem. Maybe even bigger. But officially on their specs, they list your end mill tool max size 1 inch. Part of that might come down to how big of a collet you can fit in there and get that thing to grab hold of it. Now let's talk about price. New with a good bit of tooling, it's going to run you about $7,000, maybe an extra closer to $8,000 if you throw in a DRO. And I mean, it's nice to get a new machine, but there is going to be quite a bit of setup required when you get that. So just be aware of that. It might be more setup than you'll have to deal with used machine. You're definitely going to have to adjust your Gibs more than likely. You might have to mount it to a workbench or a supplied table. But with used machines, you kind of have that questionable background. As long as you look for obvious damage, too much lash, and just keep in mind that some stuff you find, like if you have a loose crossfeed here, it's probably just a bad Gibs adjustment. And then obvious signs of, are they oiling it properly? Are they keeping it clean? Are they using it in dusty conditions? How rusty is it? Is there anything bent, broken, or missing? Another key is like, is there missing or chipped paint even? Could clue you into like, how well was this machine taken care of? On mine, it was mostly just covered in chips. And a good bit of oil mixed with some dirt. And so, and like I said, light surface rust on areas that weren't really important to the precision of the machine. And it was easy to clean up. I mean, it took me an hour to get this thing. The other thing is, plugged it in, ran it, used the power feed, used every basically adjustment I could make, every sort of interface that I could run to make sure nothing weird was going to happen. One thing with the 3-jaw chuck, I have the outside jaws here, and then I made sure I was given inside jaws as well. And then same thing with the gearing in the gearbox here. The standard gears were installed. I made sure it came with metric gears. If you come across that and you're kind of up in the air about it, I would probably not get a machine that didn't have metric gears. I mean, you can order it from Smithy to replace those, but it's going to just be a hassle. And if they lost that, it's kind of, well, how well did you take care of everything else if you happen to lose that type of stuff? The other thing I run across is, I told you, new runs about 7,000. I've seen people selling machines that are like, oh, it's only a couple years old, it's barely been used, and they're charging in the $7,000 price range. Now granted, they're including a lot of tooling, which in the weird case of Smithy, depending on when they bought it and what kind of deal they got, may or may not actually increase the value of the machine, because a lot of that tooling comes with the machine. But most of these machines out there for sale used have a dark gray finish. In 2019, or just before January 2019, Smithy switched back to a blue color that the Granite machines originally came in back when they were first released back in 1999. So anything that comes in this dark gray, as they're calling it, was produced before 2019 and is more than a couple years old. And so to figure out roughly how old your machine is, as I said, the first version came in a blue color that you can see on the website. If you go to Smithy's website, it's the color of their current machines. That's the same color those first machines back in 1999 were produced in. So if your machine that you're looking at purchasing is blue, it could either be one of these 1999 machines, or it can be one of the more current machines built from 2019 on. And one of the ways to know if your machine is current is it will have this round feed handle here at the end. The first versions of the machine didn't come with that round feed handle. The other thing is the motor on the back is a square-shaped motor housing. It's a brushless constant torque DC servo type motor. And the earlier machines had a round-shaped housing, variable speed DC motor. A little bit less horsepower, torque, and so you definitely, if you're looking for a machine, try to get one with that servo type motor, which is better. And also, as I said before, the new versions come with this round feed handle here at the end. I don't know if you can see it on the video. Maybe I'll show a close-up picture of it. The older machines did not have that. So the first version was blue, round motor, no feed handle. The second versions came out shortly afterwards, and I don't have like set years when these happened, but basically the second version that came out was that same machine, round motor, no feed handle, and that's where it switched to this dark gray color. Basically that was about the only change. Then came the machine that they titled the Classic. And so it will appear on the nameplate, say Smithy, Granite, whatever model number it is, 1340 or 1324, and then Classic. But those came out third, as far as I could tell. They kept the original round motor, but they added the feed handle, the round feed handle on the end of the feed screw. Next came the version I have, so this would be like the fourth iteration, which is the 1340 or the 1324 MX, and then also there was an IMX, and I'm not sure if those occurred at the same time and were kind of sold as like a baseline and an upgraded model, or if they happened consecutively, with my version being the fourth iteration and the IMX being the fifth iteration. I couldn't find anything real clear on that. But basically, that's probably about middle of the 20-year time span between 1999 and 2019 that those occurred. So I guess those would occur around 2010-ish, 2009, somewhere in there, if I had to make a rough guess. The MX and the IMX is where they switched to that square drive motor I was talking about, which was a major upgrade as far as Smithy Granite machines are concerned. And then I haven't seen any of the earlier versions of the machine where I can make a good comparison, but supposedly these versions and on have a mill head that is extended out, which, if you imagine this being compressed in further, closer to the headstock, you can imagine that would be really tough to use as a milling machine. I mean, really, I would love if this mill head was out even a few inches more. It would give it more usability, but it also opens up a whole bunch of design issues with this heavy piece being kind of cantilevered off of this post. So I understand why it's built that way, but it'd be awesome if it was just a little bit further out. But machines previous to the MX, supposedly that headstock might be a little bit shorter, and you might be a little bit frustrated with using that machine as a mill. Then, as I stated before, around 2019, so 20 years after the release of the first Smithy Granite, they started building machines in what they were calling their anniversary color. They went back to that blue color. It was the same machine as this, just in blue, and that's what's currently being sold on the website. Those machines also usually have a digital readout of RPM here next to the speed controller. I've also seen some dark gray machines with that digital readout of the RPM, and I think that came on the Elite I-TAC Max. And so I think between like the IMX, the MX, and the current anniversary color edition, I think there was a Elite version released, and that had the addition of the digital readout. So what's this mean when you go out and you're looking at machines and people are telling you that their machine's only a couple of years old, barely used? If it's not blue, then you know it's more than a couple of years. It's at least 4 or 5 now, if not older. And if it's labeled as an MX or an IMX or Classic, or it has one of those round motors, you know it's even older than that. It's pushing 20 or more years old. And the only way it could be a couple years old and barely used is if they're only looking at their ownership history, where they bought it off somebody else who said it was never used and only a couple years old, and they're just not really thinking about like, oh, they bought it off this guy, it was a couple of years old, they've had it for 5, now it's pushing like 7, 9, 10 years old. Either that, or they're just straight up being dishonest with you and trying to get more money than what it's really worth. They might even be trying to sell it for more than what they originally paid for. And so basically a brown machine, unless it's in like perfect mint condition, not a scratch on it, it's not going to be worth the 7,000 or 8,000 that I've seen a couple people asking for them, even with all the tooling that they're including. I mean, basically, I put in about 3 to 4 on this, and that was with purchasing all the tooling that is coming with some of these other machines. I mean, the only thing I'm short is a 4-jaw chuck, and people are asking 7 to 8 grand for a machine that has all the same tooling without a DRO even, and they're saying like, oh, it's never been used. And granted, some of these look brand new. They've probably been well taken care of, cleaned up real nice, but it's still, I mean, imagine buying a new car back in 2007, driving it home, putting it in your garage, and then never using it. You could not sell that car for the same price today, even though you never used it. And it's kind of the same way with these machines. Cars will degrade from non-use. Like seals will go bad and stuff like that. It's not so much of a deal, big of a deal for these machines, but if they're just sitting around, they're really kind of collecting rust. And I mean, sometimes you can clean it off and it's not a big deal. Like this one had a little bit of surface rust that was removed and it's not impacting anything. That puts wear on parts and it's just not worth that. I mean, if nothing else, your belts up here for your mill are going to need to be replaced because they're old enough to where they could just break first time you run the machine and put any load on a cutting attachment. So there was a couple machines, I didn't even bother contacting the people because they were saying it was a brand new machine. They've only used it a little bit, and I knew that it was at least 4 or 5 years old, depending on what they were selling. And some of them were trying to get full price tag price for stuff that was even older. I just can't imagine that when I could go out and buy a used lathe and a used mill and not pay what they were worth brand new, and they're more reliable pieces of equipment. They're supposedly better built. So there, I've covered a few things to look out for, what to expect, what the machine is able to do, really kind of its capacities, and how to kind of look at the different models and determine a good price at what you're looking at. Just a rough estimate. I mean, there's a variety out there and you're going to run across outliers to that. They're really nice machines. I definitely recommend getting one if you're limited on space and can't fit a small mill and a lathe in your garage. I don't have the space. If you've seen any of my other videos, there's a huge welder, there's a tail of an airplane, there's about to be more airplane, and I have a serious storage problem. So this is great for me. Other thing is, you're laying out $3 grand for something used, whereas if you're getting a mill and a lathe, you could expect to spend in that area if you get lucky, or more, like maybe $3 grand per machine. So now you're at 6 total. The other thing I've run into, lathes is not so much an issue. You can find those that will run off 110 or 220 or 120, 240. With mills, on the other hand, most of the ones I see that are worth getting are running off a 3-phase. And depending on where you live, it's going to cost you more than the machine to run the electrical power, or you have to run some sort of rotary converter, which depending on your machine, it could mess up your machine. And then you're out the cost of the rotary converter plus the new machine you just bought, new to you. Very accurate. I've produced some very accurate parts off of one of these that was in much worse condition. Total run out on, say, like the spindle here, that's 7/10 of a thousandths. And then I haven't checked this machine specifically, but one thing you could do if you're going to look at a machine is put a dial indicator off of here and run your cross feed in and out and your table back and forth and see what kind of run out you have on the ways of your machine. Like, see if that dial indicator jumps around. Make sure obviously your table's clean first, but that would give you an idea of how precise this is. And I'll check that later just because I'm curious what it is. I've never done that to any of these machines before, and I'm kind of curious. But the spec here on the spindle is 7/10 of a thousandth. And I haven't looked at or seen it anywhere that it lists the spec for the rest of this, but I'm guessing everything else is on that order of precision. Anyway, that's a quick overview of what this is. One thing I'll say, if you pick one of these up and you do want the DRO, you can get one on there for about 600 bucks, depending on what you buy. You can also go more expensive. Same thing with tooling. If it comes with no tooling, as long as you have this chuck, it won't sit you back too much. You can pick up a Super Lock 3-inch vise if you know where to get them. And I'll probably do a review on the one I have. Or it's Super Lock, but it's not the actual Curt, so it's not got that Curt price tag with it. And that'll run you about 150. I bought indexable bits for the lathe. I bought a whole set of 4-flute end cutters. I got the arbors and chucks, stuff like that, parallels, and I spent just roughly $800 if I remember correctly for everything except for this chuck, which came with the machine. So not really a bad deal. I mean, so you throw in all that extra tooling, I guess you could spend anywhere from 3.5 to nearly 4, but you really don't want to push beyond that unless it is a really fantastic and great shape machine and comes with a DRO. Hopefully this helps you out if you're considering buying one of these. I'll definitely be throwing up some videos on how to set it up, how to repair this, stuff like that, and hopefully do some cool projects outside of just working on the airplane. As always, if you enjoyed the video, give it a thumbs up. Think about subscribing so you can see when new stuff comes out. You don't have to hit the bell icon if you don't want the notifications. Just click the subscribe button. And as always, thanks for watching.